Next, let's consider the function y equals x squared minus 2x minus 3 over x plus 3. Now this is a rational function. We have a polynomial on top and a polynomial on the bottom, and that's what we usually define as a rational function. When we look at such a function, we want to look at the numerator and the denominator. And the first thing we usually look at is when is the numerator 0, because if the numerator is 0, it doesn't matter much what the denominator is unless it's also 0. Y is going to end up being 0 when the numerator is 0, as long as the denominator is not. If the denominator is 0 and the numerator is not, then we have a vertical asymptote, as we saw in the preceding example. So we list what we can tell about this function, okay? The numerator is x squared minus 2x minus 3, and we see when it's equal to 0. It turns out that that occurs when x is 3 or negative 1, if I've done my calculations correctly. When is the denominator 0? Well, when x equals negative 3. Denominator, of course, is your x plus 3 that we saw up here. So at negative 3, the denominator is 0. What happens if x is a large positive or large negative number? Well, let's look back at the function. If x is a large positive number, then the numerator is going to be dominated by this x squared. For example, if x is 1,000, x squared is 1,000,000. The 2x would only be 2,000. That's just hardly visible next to 1,000,000. So that and 1,000 isn't even a very big number. We could make the number even larger and make the discrepancy even greater. The point is that these numbers here become insignificant when x gets large, as does the 3 down here. So what we essentially have is the square of a very large number divided by the very large number. If the very large number is positive, well, we have the square of a large positive divided by a large positive is going to just about equal the large positive number. That is, when we divide this by this, we're going to get something that's very close to x. If x happened to be a large negative number, well, then we would get x squared over x would give us a large negative number. So we see that the graph has these characteristics. And we always want to look at what happens when the numerator is 0, the denominator is 0, x is a large positive or x is a large negative number. We can now take the information that we've collected and put it together and make a graph. The graph is going to have zeros at negative 1 and 3, the 2 points that at which we saw the numerator was 0. It's going to have a vertical asymptote at x equals negative 3 because the denominator will be 0 at that point, and we'll have the same type of behavior that we had in the previous example. And we can also determine the y-intercept. That's usually pretty easy to do. We just put 0 in for x. We get negative 3 over 3 or negative 1. So y would be negative 1. That would be our y-intercept. So if this is negative 1, we're going to have something that looks like this. So how do we put this together? Well, the numerator and denominator are both positive on this side of x equals 3. We can test that. And it follows then that when we divide this number by this increasingly small number, since the numerator and denominator are both positive, we're going to approach plus infinity. On the other side of x equals 3, the numerator is positive, but the denominator is less than 0. Okay, again, we put any number near 3 in, the numerator is going to be positive. No doubt about that. But when the denominator becomes negative, then we're going to get a negative, so that we're going to have a negative infinity, a negative asymptote here. Now, what's going to happen is, for large negative x, we have to have a large negative y. So we're going to have this asymptote coming up. It's going to turn around and eventually go back down. We haven't shown that in the figure, but that's what's going to happen here.